And how many of you guys gave yesterday's two contests, like at Coder and Codeforces? How did that go? How did that go at Coder? Okay, yeah, that's good. Like three questions. Good. We will be starting around 11:10. So, like, if any of your friends want to join, you can ask them. And like, till then, if you guys have any doubts other than today's contest, we can discuss it. Last question of which one? Today's contest or what? Today's last question. Okay, one second, let me look. Like, are you confused about like what is an interactive problem? Like, it has a bit of a different format. So yeah, so what happens is like usually you're not provided like a particular test case. Like it's like there will be a keyword they call it like it's written. It's like the graph is not adaptive. So what happens is in blog interactive problems, the person who has made the contest they provide some specific yeah like they have hidden cases. You have to like implement the logic and they will have these hidden cases and you solve according to that and see if it's your logic is working or not. One Like you can go through the blog that I've sent in the chat. Basically, what happens is that you won't have these test cases visible to you. What will happen is you implement your logic and they will have some cases. We'll check if your logic and implementation is fine, and then we'll get your answer. There you have to use flush and other keywords while solving an interactive problem. You can like go through like see what there are many blogs on the Codeforces platform itself about interactive problems. So yeah, you can go through that. Like your query was regarding what is an interactive problem, right? Or like you had a doubt in question number like the fifth problem, E. Like it has some concept of graphs and stuff, so we haven't taught it yet, so we'll discuss it later. Okay, if that is your query.
Hello everyone. Is my voice audible to you? Yeah, my screen is visible. Okay. So let's move on to the first question. I hope everyone has read the question. But again, let's read it out once. The little boy Nikita was given some cubes as a present. He decided to build a tower out of them. Initially, the tower does not have any cubes. In one move, Nikita either put exactly one cube on the top of the tower or remove exactly one cube from the top of the tower. Is it possible that after n moves, the resulting tower has exactly n cubes? So, what we have been given n number of moves, और हम लोग को दिया हुआ है m, which is number of cubes. तो हमें करना क्या है कि हम लोग को n मूव्स में m क्यूब्स को अरेंज करना है. तो हम लोग सबसे सिंपल एक लॉजिक तो पहला यही लगा सकते हैं कि अगर n कम है m से, we can never arrange that cube. Exactly. ठीक है, ये समझ में आया. लाइक तुम लोग चैट बॉक्स का यूज कर सकते हो. हेलो. हाँ, तो ये समझ में आ गया. ठीक है ना. तो दूसरा केस क्या बनता है? जब e- जब n मेरा इक्वल टू होगा m से, तब तो मेरा ऑलवेज पॉसिबल है. ये तो ऑलवेज ट्रू है. ठीक है ना. थर्ड केस होता है जब n बड़ा हो जाए. अब जब n बड़ा हो जाएगा तो हम लोग को m क्यूब्स बनाने हैं, बट हम लोग को सारे n मूव्स यूज करने हैं. तो हम लोग क्या कर सकते हैं? अगर हम लोग n+1, अगर m का वैल्यू n+1 है, तो क्या हम लोग क्यूब बना पाएंगे? m क्यूब्स बना पाएंगे? अगर हम लोग को हर एक मूव यूज करना है, और हर एक मूव में या तो हम लोग को ढालना है या क्यूब हटाना है, एग्जैक्टली नहीं कर पाएंगे. तो हमें क्या चाहिए होगा? एटलीस्ट n+2 तो चाहिए ही होगा. मतलब m n माइनस, मतलब मेरा जो डिफरेंस है n और m का, वो 2 से डिविजिबल होना चाहिए. तब हम लोग हर एक मूव में उसको रख पाएंगे और दूसरे मूव में उसी क्यूब को हटा पाएंगे. ये क्लियर हुआ? हाँ एग्जैक्टली, एक्स्ट्रा मूव मस्ट बी इवन. हाँ, तो ये क्लियर हुआ. तो लेट अस मूव टू द कोड. यही करना था हमें इस प्रॉब्लम में. लेट अस मूव टू द कोड. तो हम लोग क्या कर सकते हैं? हम लोग n और m इनपुट लिए. अगर n छोटा है तो नो, n इक्वल है तो यस, और अगर डिफरेंस 2 से डिवाइड हो रहा है तो यस, वरना नो. ठीक है. लेट अस रन फॉर द टेस्ट केसेस. इट इज टेकिंग टाइम बट यू गाइज नो. हाँ, ठीक, आ गया. ठीक है. कोई डाउट इस क्वेश्चन में? एवरीवन, कोई डाउट? नो. So let us move to next question. So I am handing over to Pratmesh.
Hello, am I audible to everyone? Like, so how many of you solved the second question? I think one or two people solved, right? Shaunuk solved and Solanki solved, right? So what was your approach and logic? It was very observation based. Like, like how many of you guys initially thought you can just use the binary representation of your n? Like, did anyone think that? Yeah. So actually, they gave kind of the wrong problem statement initially. So like, let me share my screen. Uh, 1 second. One second. I'll just share my screen. There's some issue. But yeah, basically, okay. Huh. Okay, for some reason I cannot share my screen right now, but let's just like discuss the initial question. Okay. So what they had asked you was they provided you with an positive integer x, and they asked you that if you can create an array. Uh, the formula was like x equal to summation from 0 to n minus 1 ai into 2 to the power I. Okay. So that pretty much sounds like a binary representation if you can have like ai equal to 0 or 1. Okay. So what they had an additional constraint as that your ai can be either 0, 1 or minus 1, right? So how do you approach this? You will initiate, and they had asked you that there does not exist an index I such that AI not equal to 0 and AI plus 1 not equal to 0. So like that part was a bit confusing. Then because then your normal binary representation should satisfy the given conditions, but later they corrected it that AI and like the absolute value of AI and AI plus 1 shouldn't be greater than 1, if that makes sense. Like if you had 1 and minus 1, 1 and minus 1 cannot be like together in one place. Okay, so is that clear? Like what had happened? Yeah, okay. One second. Is my screen visible? No, no. Okay. Is my screen visible or is there some issue? Can anyone tell if my screen is visible or not? No, right? Okay, one second. Let me join once again. Okay, one second. Okay, for now, let's discuss like this. There's some issue with the screen share. So I'll show you guys the code, or like if I have to, I'll share it in the group. Okay. So someone sent in the chat, right? Can you resend that message? Like your logic. I think your logic was right. So what happens is if you think of a binary representation, what happens in the case of 3? You will get something like 0 1 1 as the binary representation. Everyone agrees with that? 0 1 1 for 3? Yeah. Huh. Okay. So what happens is if uh, your number is suppose divisible by, well, like if you write the binary representation of your number, you will get something like 0 1 1, or maybe for 5 you'll get 1 0 1 according to the conditions that Codeforces gave us, which was like AI and AI plus 1. For any index it should be less than equal to 1, right? So how can does 5 satisfy that condition? How many of you guys think, like, what is the binary representation of 5? Can anyone tell quickly? 1 0 1, yes. So as you can see, 1 0, that is less than equal to 1, and 0 1, that is also less than equal to 1. So 5 is fine. But what about 3? Is 3 fine? Like 0 1 1, you will get 1 and you'll get, yeah, like, yeah, 0 1 1, you can like 0 1 and 1 1, so that is 2, so that cannot be possibly used, right? Since we have minus 1 as like a possible coefficient, can we write it as 4 minus 1? Is that part clear? Yeah. 4 minus 1, 3. So you will see a pattern here, like if it is divisible by 2, you'll be like, okay, I can pass 0 into my array. So, like, for example, if you go for 16, what will be the binary representation? It will be 1 followed by like 4 bits or 5 bits. Okay. So, like 16, yeah. Right. As Sona wrote, minus 1 0 1. That will be your array. So in case of 16, you will get something like 1 0 0 0 0. Yeah, something like this, right? Huh. So this satisfies your condition of ai plus 1 less than equal to 1, right? Like the absolute value. But the main issue is arriving when you are having odd numbers. Okay. And in odd numbers, you are getting two cases. One is where you like use minus 1, and where you don't have to use minus 1, as we saw in case of 5 and 3. So what do you think can be like a possibility of separating these two? Like for what value of some power of 2 we'll get different remainders for these two? Because if you take the modulo with 2, you'll get the same 1 as remainder, right? But as we saw, 101 and 011, they don't like one satisfies the criteria, the other doesn't. So actually what will happen is you check if it's divisible by 4. Okay. Since you already checked if your number is divisible by 2, the other possibility is your number is odd. Okay. So when you check if it's divisible by 4, one possibility will be that the remainder is 1. Okay. So what happens when the remainder is 1, as in the case of 5? So 5 mod 4 will give you 1. Now, and the binary representation of 5 is 101. What we want to do is we want to make sure there is space between each 1 or minus 1. Okay, if you put like between each one, you want to put some space. So how can you do this? For example, if you have 3 3011, so you will get something like as you can see, 1 is consecutive. So I want to put like add an extra space between this. I'm going left to right. Okay, so your array output will be in the opposite order. Okay, so yeah, so 3011. So I want to make a space. So how can I write it? I can write it as 2 square minus 1. And how can you write minus 1 as 2 to the power 0? So basically what will be your new array, possible array? You'll get at the third bit, you will have 1, like, yeah, minus 1 0 1. Okay. So what we are checking is if your remainder is 3, you will go for minus 1, because uh, when the remainder is 3, you'll find that certain set bits, or like bits of 1, they will be consecutive. So we want to add a space in between them. How can we add the space between them? If you add a minus 1 as a like a coefficient into your answer array, you will shift it by 0, and you'll have to add an extra bit. For example, if you normally what you will do for let's say 17. 17 is what? 2 to the power 4 plus 2 to the power 0. Okay. So how can you write that? The binary representation, you will get something like 1 0 0 0 0 1, something like this, right? Yeah. Okay, I went for an extra. But anyway, so what will happen is you will get something like this. So this is fine, because it is when you divide it, like take the remainder with 4, you'll get like 1 as your answer. Now, tell me one thing. If you have your remainder as 2 or something else, what will happen then? Why are we not taking the case of like we're taking the case of remainder 1 and 3, right? Why not 2? Like 0 is already accounted for, because when you check for 2, you'll get like, if it's even or not, you will get the remainder 2. Otherwise, the possibilities are 1 2 or 3, right? So what happens is, as we already said, that when you write the binary representation of your numbers, you will see if you have a number which is like giving remainder 3, you want to add a space between them, hence you will add like a minus 1. Otherwise, what you will do is you will you're like if the remainder is 1, you don't have to do anything. You'll just push 1 as your answer to the array. Okay. And then you can just like do a check if your remainder is 1. What you want to do is you want to remove a 1 from it. Okay. So whenever you remove one from it, it will again become something that is divisible by 4. That is our target. And when in case of remainder 3, you want to add like 1 to it. Okay. So with that logic, you can implement that part. As I cannot share my screen right now, I will like send the code in your like the 2327 group. So don't worry about that implementation part. But how, like, is the observation clear to you guys? Like how we are using the binary representation? Like if you guys have doubt regarding the binary representation, you can tell us. Like someone else might share the screen, I can just walk you through it. Okay. One second, let me check one more thing. Whiteboard. Can I use? Am I audible to you guys? Like, can you hear me? Yeah. So like, two of you guys solved this question, right? So that is great. What about others? Did you guys understand the logic? Logic समझ में आ रहा है कि like observe क्या कर रहे हो? Like initially if you read the question, तुम लोग को लगे कि -1 क्यों डाल रहे हैं? बट लाइक -1 क्यों डाल रहे हो उसके लिए तुमको एक्चुअली जो करेक्टेड उन लोग ने स्टेटमेंट प्रोवाइड किया था, यू हैव टू लुक एट दैट. अच्छा, like let's go through the implementation. I'll try one thing. Okay. Okay, so I think the screen is visible to everyone right now. Like if it is, you can like say yes or no, right? Raise your hand or something. Okay, so we can know if it's visible. Okay. Hello. Yeah, so if you see this part of the code, you will see if you find that your number is even, you'll just push 0 because adding 0 does not violate your criteria of AI plus 1 less than equal to 1. Okay, that part is clear to others who didn't solve this question. Okay, so adding 0 is fine. Now you have to check if x mod 4, because we've already checked if it is even. If it is not even, we'll check if it is divisible by 4 or not. Why 4 specifically? You can see like what is happening is we are shifting this by 2 bits, right? uh, you guys have some idea about binary numbers, right? Like it is, you can represent everything in powers of 2. So why we are checking with mod 4 is you are trying to shift it by 2 bits, right? Like the difference between your current bit and the like bit which is next to it is 2. But if you want it to be at space 4, so you need to shift it by 2 bits. To do that, we'll As you can see, if it's divisible by 1, I'll add 1 to it, because that part is fine, right? As we discussed in the example of 5. But if you check for like something like 3 or 7, you will find that the bits are consecutive, so you need to add a minus 1. So what can happen is you can then use a higher bit. For example, for 7, how can you write 7? There are two possibilities. Like mainly one possibility, but yeah, either you set all your 3 bits to 1, that is 1 1 1, or what you can do is you can write it as 8 minus 1, right? So what happens when you write it as 8 minus 1 is you will get a gap between your consecutive bits. This bit part is clear. I think that might be a bit doubtful. Hello? If it is clear, you guys just write it in the chat box. Okay. Yes, okay, it's clear. So after that, what you do is simple. That this much part is only the implementation. The main thing was observing what happens when you find consecutive bits. Like as you so you can scroll down a bit. Okay. See, this much part is clear to everyone. And since we are using pushback, pushback just adds it to the end of your vector. Vector is basically use it like an array. So simply use that. And there isn't much else to this code. For the third question, if you guys see it, it actually uses the concept of dynamic programming, and you will need some mathematical formulas. So, like dynamic programming, there is this very common question about subsequences. We'll share some resources about it. What happens is you check if your current the actual problem is, I think, something like can you form a subsequence that makes the sum I, so your dp of I is that, something like that. Okay, we'll share the resources. And like this question, if you guys have doubt, you can like tell us in the group. We'll discuss it there, but since we have not discussed dynamic programming in our classes, we'll discuss it sometime later. So till question number 2 is clear, I think. Like, right? Shaunak, Ahina, Prithvi, you guys, is it clear? Okay, what about others? Because I think only two people solved it. And I would suggest you guys try problem. See, it might be a bit difficult, but like this is diff 2, right? So, but the main idea would be think if you guys have studied DP, or like you can find some resources online. What you can try to do is you can uh, try to find what your DP state can be. We can help with that, I think. You can know, like till index I, what will happen, or something like that. So yeah, try this question. If you face any difficulties, tell us. Uh, we'll share the codes and resources. So do you guys have any other doubts regarding today's contest or yesterday's contest? And just like write yes, no, something. Okay. And if there are no doubts, we can end today's meeting. Okay. Hello. Am I audible to everyone? I'll just one second. I'll copy paste the code in the chat box for you guys to see. So if you guys want to go through it, I think I didn't copy all of it, right? I did copy all of it. No. Okay, so like if you guys don't have any doubt, we can end today's meeting. And if you face any difficulties, you can tell in the group, okay, or your mentorship group, anywhere you find comfortable. You can reach out to us. We'll share today's recording and the solutions to the problems.